We usually think of science and, say, philosophy or spirituality as being in completely separate worlds. But what if they aren't? What if there's a kind of bridge between them, a hidden language that seems to connect the logic of physics to the deepest questions about reality? Well, today we're exploring that exact bridge, and it's made of mathematics.
And that brings us right to the heart of the matter. It's the central question for this whole explainer. Is math just a handy tool that we humans invented to describe the universe, or is it something more, something we're discovering, a kind of fundamental code that was already woven into the fabric of reality itself?
So here's our game plan. We'll start with this idea of the universe's hidden language. From there, we'll see where science meets a mystery, and then dive into the absolutely incredible story of Ramanujan's prophetic math. We'll look for echoes across time, and then we'll hit a really important skeptic's checkpoint before we try to pull it all together and ask, what does it all mean?
All right, let's jump in. First up, the universe's hidden language. This is all about exploring that fascinating intersection where logic, intuition, and reality seem to overlap. Our journey really begins right there, where the cold, hard logic of numbers meets the actual universe. It's a place where science kind of quietly opens the door to a sense of wonder.
This brings us to our next section, Science Meets a Mystery. We're going to see how some of the greatest scientific minds in history dealt with the profound order they saw in the universe. And what's so cool is that this feeling of awe isn't just for poets. The most rigorous logical thinkers have looked at their own equations and seen something deeply mysterious.
I mean, just take a look at Albert Einstein. He wasn't talking about organized religion here. He talked about a cosmic religious feeling. For him, it came from seeing the harmony, the pure elegance of natural law. He felt it revealed an intelligence so far beyond our own that human thinking was just an insignificant reflection.
And this isn't some new age idea either. Let's rewind a few centuries to Isaac Newton, the guy who basically invented classical physics. He looked at that same ordered cosmos, the planets moving in their predictable paths, and came to a pretty direct conclusion. This has to be the work of an intelligent and powerful being.
Okay, now let's fast forward to the 20th century and the bizarre world of quantum mechanics. You'd think that would be the end of order, right? But one of his founders, Werner Heisenberg, saw the exact opposite. He believed that the deeper physics digs, the more mystery it reveals, not the more it explains away. It's like mystery is a fundamental layer of reality itself.
So you see the pattern here, right? It's unmistakable. From Newton's clockwork universe to Einstein's curved spacetime and Heisenberg's quantum fuzziness, it seems the greatest scientific minds don't just find answers, they find bigger, deeper, and way more profound questions. The mystery just gets stronger.
Now for what might be the most mind-bending example of this entire phenomenon. Section 3. Ramanujan's prophetic math. This is a story of mathematics that genuinely seemed to come from the future, through a man whose work felt like it was beamed in from another time. Meet Srinivasa Ramanujan. He was a mathematical genius from colonial India, largely self-taught, who came up with thousands of original theorems. So what was his process? Well, he said the insights, the equations themselves, were given to him in dreams by a Hindu goddess. Think about that. He wasn't inventing them. He felt he was receiving them. And this is where the story becomes a true paradox. It's 1920. Ramanujan is on his deathbed, and he writes down these things he calls Mach theta functions. For decades, the world's best mathematicians have no clue what they're for. Then, jump forward to the 70s, 80s, and beyond. Physicists are tackling one of the biggest mysteries in the cosmos, black holes, and they realize Ramanujan's functions perfectly describe their entropy. How? How could he possibly have known the math for something that wouldn't even be deeply studied for another half a century?
Okay, Ramanujan's story feels almost supernatural. But this idea of a deep underlying order, it's not just a modern scientific thing. Let's look for some echoes across time. We're going to connect the structure of modern mathematics with some really ancient philosophical concepts.
Just look at this parallel. In modern science, we have mathematics. It's the language we use to describe the laws of physics. In ancient Vedic philosophy, they had a concept called Rita. This was the principle of cosmic order, the thing that governs all harmony and truth in the universe. You see, two totally different cultures, thousands of years apart, both pointing to the same fundamental idea. Reality has a structure. It's not just random chaos.
And if you want a symbol of that perfect hidden structure, there is nothing better than this right here. Euler's identity. People call it the most beautiful equation in all of mathematics, and you can see why. It's so simple, so profound, and honestly, deeply mysterious.
So what makes it so beautiful? Well, it connects the 5 most important constants in all of mathematics, and it does it with stunning simplicity. You've got E, the number behind all natural growth. You have pi, the number that defines every circle. You've got I, the imaginary number that's essential for so much of modern physics. And then you have the 2 most basic concepts of all. 1, the idea of unity, and 0, the idea of nothingness. All of them, from completely different areas of math, tied together in one perfect equation.
Okay, so it's really easy to get swept away by all this wonder, right? But we've got to be intellectually honest here. So let's hit pause and go to the skeptic's checkpoint. We need to ground ourselves and consider the counter-arguments.
So, here's the other side of the coin. It's very possible that our human brains are just wired to see patterns and find beauty in things like equations. And the idea that the universe is fine-tuned for us, well, that could just be selection bias. I mean, of course we live in a universe that can support life, because if it couldn't, we wouldn't be here to talk about it. And this is a big one. Just because an idea is logically perfect doesn't mean it's physically real. These are really important points that add a necessary balance to our exploration.
And that brings us to the final section. What does it mean? We've looked at the mystery, we've considered the skepticism, so where does that leave us? It's time to try and synthesize all of this, the science, the math, the philosophy, and see if we can get a clearer picture.
Maybe a good way to think about it is with these 3 lenses. Science is the lens that tells us how reality works. It describes the behavior of the universe with incredible accuracy. Mathematics seems to be the lens that shows us the underlying structure, the blueprint, if you will. And that leaves philosophy with the biggest job of all, to ask what it all means. Why is it this way and not some other way?
And this leads us to one final, huge thought to leave you with. The more we learn, the more it seems like meaning might not be something we impose on the universe, but something that's already encoded within it. So maybe the question isn't just, what are we? But also, what are we part of? What if we are the universe's way of becoming aware of its own elegant structure? Now that is something to think about.